Welcome back aliens, my name is Davin Reddy and let's continue with the series on Python. In the last video we have talked about a sorting technique which is bubble sort, right? In this video we'll talk about selection. But what's wrong with bubble sort? The problem is in every iteration, first of all we do multiple iterations, right? Because we have to make sure that you get assorted values and at one point you swap two values. The thing is, in each iteration, you do multiple swapping, right? If you remember, we have done multiple swapping. So there's nothing wrong in traversing from start to end, but swapping consumes a lot of processing power. So we don't want to do that. We don't want to consume our CPU power and memory to do that. So swapping should be done only once, and that's where selection sort comes into picture. So in selection, what we do is we go from start to end and we find either min value or max value depending upon different implementation. In this example, we'll go for the min value. So what you will do, you will go from start to end and you will find the min value. So in each iteration, you will do only one thing, which is you will find the min value. So let's take this value. So we have 5, 3, 8, 6, 7, 2, the same values which we have taken for bubble sort. So what you will do is you will go from start to end and you will find the min value. And we all know how to find a min value from a list. So let's say you will assume that the min value is the first value. So you will say, hey, min is first. But then you will start comparing the first value with each element. So you will say, hey, my min value is 5, but then let me compare 5 with the next value, which is 3 in this case. And now you know 3 is the min value. So you will say, hey, the new min value is 3. Now you will compare 3 with the next value, and then the next value, the next value. And at the end, you will verify, hey, now 2 is the min value. So at the end of first iteration, you got the min value, which is 2. And now we know 2 is the min value. So what you will do is you will swap 5 with 2, right? Because we started with 5. So now you will swap 2 with 5 and your 2 goes at the first. Now you know after first iteration that 2 is the min value and it is fixed. So what we are doing is we are creating two different arrays here. One is sorted array, second is unsorted array. So the 2 becomes a sorted array. Now from the remaining elements, what you will do, again you will do the same thing. You will find the min value. So you will start from the first value and you will go to the end value and you will say, hey, now 3 is the min value. So after going from start to end, you got 3 as a min value. And if you can see in each iteration, we are doing swapping only once. So what you will do, you will swap the values with 3 becomes your second value. And now 2 and 3 becomes part of the sorted array, and the remaining value becomes part of unsorted array. After some time, you will do the same thing, right? With each iteration, you will start skipping the values, right? After first iteration, we skip 2. After next iteration, you will skip 3. And then you will now skip the next min value, which is 5 in this case. And the list goes on. At the end, you will get a sorted array, right? So let's try to implement that in this example. We already have a code here. You can see we have a sorting method and then we have a list of values and then we are saying sort and then we are printing it. This is what we have done in bubble sort, right? The code which we are saying here is a bubble sort. What changes in selection is the logic, right? So you will change this part. The list of elements is same. The sort method will be having the same name. We can have a different name, of course, but let's keep it simple. And now here, let's write the actual logic. Now, of course, when you say you want to go for the multiple iteration, you need two loops, right? Nested loops. So you will say for I in range. Now what type of range I want to define? So you can go with min value, you can go with max value. Now when you go for max value, you go from the highest value to the lowest value. So the highest index to lowest index. In this case, we will find the min value. So you will go from the low index to the high index. Low will be 0 and the high index would be 5. So you will simply say range of 5, right? You want to reach till 4. Now once you got that, you also need a variable which will hold the min position. So I will simply use min pos, which will hold the min position. And by default, I would say that is I. When your I starts with 0, I will simply say, hey, min position is 0. When your I starts with 1, your min position becomes 1, and so on. So normally what we do is we say min position is 0, right? But we'll not do in this case is because after every iteration, we are fixing the sorted array, right? And in that, the 0 index is gone. So we cannot simply reuse it. And that's why I'm changing the min position to I every time after every iteration. So let's use another loop here, nested loop, right? So we have to say for j in. Now the range of j, okay, so after every iteration, you can see we are creating that sorted array, right? So we have to reduce the size of our unsorted array, and that's why the range of this will be lowered. So we'll say range, it will start from I, right? And we have to go till, let's say 6, because the size is 6. It will go till 5, the inner loop, okay? The only thing we have to do here is we have to find the min value. How do we do that? So we have defined the min value as I, right? So in this case, if you look at these values, so the value of I would be 0. So min value will be 0, min position 0, and the value at 0 is 5. So we are assuming that the lowest value is 5. And then you will start comparing 5 with each value, which is with 3, with 8, and so on. The moment you find the min value, you will simply change the min value. You will simply change the min position. So you will check if nums of j is less than nums of min pos, because by default min pos is minimum as per our knowledge. But then the moment you find a value which is lesser than the min pos, you will simply change the min position, right? And so in this case, if you find it, you will simply say min pos is equal to j. So you got a new position. That's it what you do. So you can see after completing the iteration, you only got a min position, and at the end you will simply swap. That's what we are doing from a long time, right? How do we swap? So you take a temporary variable and you say nums of I, nums of min position. So you can see what we are doing here is we are taking a temporary variable and then we are swapping the index value I, because if you can see we are going from start to end, and we have to make sure that after every iteration you are getting one fixed value. So you will not simply keep swapping the elements every time in the j loop. You will do that in the outer loop. So you will swap only once, and that's why we are taking I index here, not j. So you are swapping the index I with the min position, and at the end you will get this sorted array. I will simply say run this demo. Oh, it works. You can see that we got 2, 3, 5, 6, 7, and 8. So values are getting sorted. But I want to know how it looks like after every iteration. Okay, so after every iteration, after swapping, how it looks like. So I will simply print the nums just to see how it looks. So let me just run this code. And this is how it looks like. So initially you will see we got 2 as the min value and 3 was there as it is, and all the elements are at the same place. So we are swapping 2 and 5. Can you see that we got 2 and 5 swapped? Now 2 is the min value, that's why, and 5 because the initial value of I was 0. And then we are swapping. You can see the next iteration is 3 as it is because 3 was there where it's supposed to be. In the next iteration, we are swapping 5 and 8. Now why 8? Because it was third iteration, and in the third iteration your I value would be 2, and so index for 2 was 8, and you are swapping 8 with 5. That's what we are doing here. That's why we are saying nums of I, and the list goes on. You can see we got all the values sorted. So this is the advantage of using selection sort, because you are not doing swapping multiple times. I hope you enjoyed this video. Let me know in the comment section and do subscribe for further videos. Bye bye.